Hello friends, I am Gitanjali Gadri, Assistant Professor, Department of Statistics in Rajashri Chhatrapati Shahu College, Kolhapur. Today topic is stratified random sampling. Introduction is in simple random sampling we have seen that the precision of estimate of population properties depends on the homogeneity of population. For example, simple random sampling without replacement it is denoted by SRSWOR. The estimate of population mean is given by sample mean means y bar and its variance is given by variance of y bar is equal to formula is capital N minus small n divided by capital N into small n into s square. When put this value is s square, variance of y bar is equal to capital N minus small n divided by capital N minus 1 into sigma square by n. If units in the population are homogeneous, then variance sigma square and population mean square s square are large and consequence variance of y bar is also large. Thus, in case of heterogeneous population, the estimates given by simple random sampling are less precise. In order to overcome this difficulty, one has to search new method of sampling which will give estimated random sampling. Definition of stratified random sample is consider a population consisting of capital N units. These small n units are divided into k homogeneous and non-overlapping subpopulation of size capital N1, capital N2 up to so on capital Nk respectively, such that summation of I is equal to 1 to k Ni is equal to small n. Then the combined sample of size n is known as stratified random sample, and the technique of drawing such a sample is called as stratified random sampling. Notation is capital N means number of units in the population, capital Ni means number of units in the ith stratum. I is equal to 1 to up to k. Summation I is equal to 1 to k. Capital Ni is equal to capital N. Pi is equal to capital Ni divided by N means ith stratum weight. I is equal to 1 to up to k. Capital Yij is equal to observation on jth unit in ith stratum. I is equal to 1 to 3 up to k and j is equal to 1 to up to Ni. Y bar I is equal to ith stratum mean summation of I is equal to 1 to Ni Yi j divided by Ni. Si square means ith stratum mean square. I divided by Nj minus 1 summation of j is equal to Ni Yij minus y bar I bracket square. Sigma square means ith stratum variance 1 divided by Ni summation of j is equal to Ni Yij minus y bar I bracket square. Y bar is equal to population mean summation I is equal to 1 to k summation j is equal to 1 to Ni Yij. Let n is equal to size of stratified random sample. Small n is equal to size of simple random sample drawn from ith stratum. Summation of I is equal to 1 to k, Ni is equal to n. I is equal to 1 to k. Yij is equal to jth observation in the sample drawn from ith stratum. I is equal to 1 to up to k. J is equal to 1 to up to n. Yi bar is equal to summation j is equal to 1 to ni Yij divided by ni. Sample mean of the sample drawn from ith stratum. I is equal to 1 to up to k. Y bar is equal to stratified sample mean. Summation of I is equal to 1 to k. Summation of j is equal to 1 to ni Yij divided by small n. Then 1 by n is equal to summation I is equal to 1 to k ni into y bar I. And small si square is equal to sample mean square for ith stratum. Therefore, 1 by ni minus 1 summation of j is equal to 1 to k Yij minus y bar I bracket square. First theorem is in stratified random sampling, weighted mean of sample mean is not an unbiased estimate of population mean. Proof is since a simple random sample of size ni is drawn from ith stratum, hence expectation of y bar I is equal to capital Y bar I is equal to 1 to up to k. In stratified random sampling, the sample mean is given by small y bar is equal to 1 by n summation I is equal to 1 to k, summation j is equal to 1 to ni, Yij. The next step is 1 by ni, 1 by n, summation I is equal to 1 to k, ni into y bar I. Therefore, expectation of y bar is equal to expectation of 1 by n, summation of I is equal to 1 to k, Ni into y by I. Next step is 1 by n summation I is equal to 1 to k. Ni into expectation of y by I. 1 by n summation of I is equal to 1 to k. Expectation of y bar I is equal to capital Y bar I. Then put this expectation of y bar I value. Then Ni into capital Y bar I. Next step is 1 by n summation I is equal to 1 to k. Ni into expectation of y bar I. Then 1 by n summation I is equal to 1 to k. Ni into capital Y bar I. Therefore, expectation of y bar is not equal to capital Y bar, means 1 by capital N summation of I is equal to 1 to k Ni into y bar I. Therefore, sample mean is not an unbiased estimate of population mean. Thank